What's up, everybody? It's Monday, so what better system to go over on a Monday is equipment cooling. It's everybody loves doing it. Everybody loves Mondays, right? No, sorry. I know no one likes this system. I don't care. I don't mind it. I teach it, relatively all the time, so I've learned it pretty good, and I don't mind it. Some things might sound a little bit different, look a little bit different. Notice how I'm all cut out, right? I'm not at home. I'm not in my normal area. I don't have my normal computer or my normal microphone or anything else. But I couldn't resist making a video about the equipment cooling system for you guys. So I apologize that things are a little bit different, but it's okay. We'll make it through. So let's just jump straight into it. Nobody wants to drag this out any longer than they have to. So if we take a look at our equipment cooling system, it's a pretty simple system. It really is. I know people get twisted on the lights and what comes on, what turns off. I'll walk you through it. It's fine. It's not hard. But this is a general breakdown of the equipment cooling system and what's in it. We have a couple, three valves, technically four valves. We have our bypass shutoff that's located right here. That's our bypass shutoff. We have our inboard supply that brings in air into the system. Smoke override valve, overboard exhaust valve. We'll talk about what those do when we get into some of the non-normals of the system. And then we have two fans. You can see we have the supply fan that's there in blue and the exhaust fan that's in red. And we'll talk about that too. So you got your supply, your exhaust, and then you got a valve over here for conditioned air. It's your manifold interconnect valve. So basically what this does is it allows conditioned air to come into the system for certain settings. So it's real quick breakdown. That's all it is. And this is going to be set up as a slideshow, obviously, if you can't tell. And it's only about 19 slides, and we're already on slide 2, so you're making it pretty good. All right, number 3. So if we look here, this is a situation of the aircraft being on the ground. Engines and packs are turned off, and the skin temperature is below 45 degrees. Now, one thing this schematic doesn't really have is it doesn't have a good indication of the skin heat exchanger. Okay, so the skin heat exchanger would be right in this area here. Okay, and if we want to think about what a skin heat exchanger is, so heat exchanger, skin, that's what it is. It's a heat exchanger that's right up against the skin of the airplane. When the skin of the airplane is cooler, the heat exchanger is more efficient. Okay, so because it's like a heat sink, it's pulling that heat out of that. It's a radiator. That's what it is. Let's just call it what it is. It's a radiator that air flows through, and it's like a heat sink into the actual skin of the aircraft. Okay, so whenever the temperature is below 45 degrees Fahrenheit, the skin of the aircraft is below 45 degrees Fahrenheit. This bypass shutoff is open. And if it's open, it allows air to come through that skin heat exchanger and back into the system because it's efficient enough to cool the air down enough to be able to go back into the system without making it overheat. Okay, so now if we go from this, which is below 45 degrees, to this, which is above 45 degrees, so we can see there's a significant difference, right? This bypass shutoff valve closes. Air is no longer allowed to come through that skin heat exchanger that's located right here. And now you have the overboard exhaust valve open. Now, when you do your walk around, the overboard exhaust is about yay big, and it's on the bottom side of the airplane behind the nose gear. Okay, so when it's above 45 degrees Fahrenheit, 50, 60 degrees, whatever, if it's chilly outside, you see people huddled around that area. That's why. It's because it's dumping off warm air. If you're doing your walk around, you get a burst of warm air as you walk past the nose gear. That's why. It's because you got this hot air coming out of this hole because it's dumping it off because it can't cool it through the skin heat exchanger because the skin of the aircraft is too warm. Okay, so we still have supply fan running, still have exhaust fan running. Our interconnect valve here is not switched to conditioned air yet. So we literally, we have a supply fan shoving the air in. We have an exhaust fan pulling the air through and then dumping it over the side. Okay, so far we're still all normal configuration, normal settings in the auto mode. Same here. Okay, now we've started the aircraft. Now the engines are on. So it doesn't really matter what the temperature is now. It doesn't care. Doesn't matter if it's 45 degrees Fahrenheit. Doesn't matter if it's 70 degrees Fahrenheit. Doesn't matter if it's 80 degrees, 100 degrees, whatever. It closes this overboard exhaust right here. And it opens this bypass, or the bypass shutoff opens up again, and the air just gets blown around again. That's what happens. The supply fan is still on, the exhaust fan is still on, but the air is recycling itself inside the system. So, with that being said, be careful, or be cognizant, I guess. Not really careful. There's not really anything you can do. This is all an automatic system. Be cognizant of the fact of what the temperature is outside. If you're in Phoenix in the middle of summertime, it's 120 degrees outside. If you're in Qatar, Bahrain, Texas, Florida, whatever, when it's ridiculously hot out in the summertime, this could pose a problem if you have to sit in the conga line waiting to get, off the ground. So that is a potential problem. Simply because those fans can only do so much to cool that air down as it's going through the system, right? And remember, it's going through the system through a skin heat exchanger. So if your skin's hot, the skin of the aircraft is hot, it's not going to cool that air down at all. It's just going to let it either keep heating up or just keep it at the temperature it is. So just something to think about, right? There's no way to fight it. This is just how the system works. Now, this is in flight. This is aircraft in flight. So let's take a look at the differences here. So aircraft on the ground with the engines running. Air comes this way. Both fans are working. Okay. Now we go here. Fans off. But our interconnect valve has now moved to conditioned air, which means that now we're getting conditioned air entered into the system. Okay. And that does pretty good for us because now we have cooler air coming into the system. And that's what we all want. We want it to be cool in there because if it overheats, you start to lose stuff. And we don't want to do that. We want to keep it as cool as possible. So even though I don't have that supply fan running anymore, I have that exhaust fan that's able to pull that conditioned air through this system. Okay. Now, in this case, when we look here, the overboard exhaust has stayed open. Now up here, I've made a mistake. I put all valves closed except for the bypass shutoff valve. That's not true. In this case, it's the overboard exhaust that didn't close. So that's my mistake. I'm going to go back and fix it. But for the purposes of this video, it's the overboard exhaust that's open. And that's pretty self-explanatory looking at the picture, right? Now, the valve light's going to come on. And if you remember what we've said with all these other systems, a valve light is either in transit or a disagree. Well, in this case, it's a disagree because it should be closed and it's open. So that's why the valve light's going to be on. The problem with the overboard exhaust being the one that's still open is the fact that it could cause your airplane not to pressurize. Because, again, it's a hole like this on the bottom of the airplane. And even if you're running both packs high flow, it's not going to matter. You're not going to be able to pressurize the airplane. It's a giant hole. So that's why we have to fix this. Again, everything is going to be predicated on company manuals, QRH, etc., and your company policies on how you're going to do this. But the technique is that you point the switch to the light. That's really what it is. And I can almost guarantee you with like 90% certainty that your QRH is going to direct you to do the same thing. You're going to run this valve light for the equipment cooling. It's going to tell you to move the switch to standby. And then the valve light will extinguish if everything moves back, because going to standby does a couple different things. So what that looks like is this. Okay, so we move to the standby position. That standby position does two things. The first thing is it's going to give a signal out to all the valves as a get right signal saying, this is the position you're supposed to be in. Get in that position now. Okay, that's the first thing it does. The second thing it does, now this all happens instantaneously, so it's not like it does one then the other. It does them both at the same time. But the second thing it does is right here. It switches. So if we look here, right, supply fan off, exhaust fan on, supply fan on, exhaust fan off. Okay, so it switches my position of my fans as far as which one is operating and when, for that matter. But in this case, it fixed our problem, closes the valve, turns the light off, or extinguishes our valve light, right? And then switches our fans. So in this case, we can continue to operate in this setting and be perfectly fine. It's not going to be an issue. Now, separate day, new jet, new day, new problem, right? So now we've got what appears to be an overheat. So we're in the auto position. Remember, our valves are all closed. We're off the ground. So our conditioned air is coming in, but now we don't have the exhaust fan pulling that air through. Okay. So we overheat because there's no airflow. We're literally putting conditioned air in there, but it's not getting pulled through the system like it normally would. So again, what do? We run the QRH. First off, that should always be your answer for any non-normal is I'm going to run the QRH. And in this particular case, you're going to run the QRH. It's going to tell you to point the switch to the light. It's going to tell you to go to the standby position, just like it does for the valve light. Now, remember how I said it does two things? It tells my valves where to go, and then it switches my fans. Okay, so let's say that this was the reason I'm overheating. The exhaust fan failing is why I'm overheating. I go to the standby position. It turns my supply fan on in this case. So now the theory is the conditioned air is going to come in and it's going to get blown into here. But this fan being on is going to create a pull, and it's going to pull that air through the system like it always would. Now, if you notice over here, it says condition standby selected, overheat lights inhibited for 5 minutes. Okay, so the overheat light extinguishes whenever we go to the standby position, regardless of whether or not the overheat condition is gone or not. Because what it's doing, it's giving the system a chance to change and to operate correctly. That's really what it's doing. So it gives it 5 minutes, and then after the 5 minutes, it tests itself and it says, okay, is it still warm? Yep, it's still warm. Oh, crap. And then it puts the overheat light back on there. If it's not warm anymore, then the overheat light stays extinguished and you can continue operating in the standby mode. But, like I said, if it's not corrected, the overheat light comes back on after 5 minutes. Now we have issues. Now we're going to have things start to fail if we don't follow the QRH and go to the next steps. If you get into a situation where there is no airflow and there is an overheat situation, you're talking about now you're going to start losing non-essential equipment basically immediately. Like it starts dumping that stuff off and shedding it and just getting rid of it to where it can conserve the heat inside that area. Essential equipment, you got about 90 minutes. So you got about an hour and a half to make a decision and land. Okay. But before you get to that point, you got one more thing you can do. And that is the override position. So the override position does a couple different things. First thing, shuts off both of my fans, turns them both off, and then it opens my smoke override valve, like I said, is on the left side of the airplane, down probably about midway down the fuselage. And it's a hole. It's about that big, not real big, just big enough to where air can flow out of it, right? So what happens is when that opens, it creates a venturi and it pulls that air right out the hole, which is pretty cool, as long as it works and as long as the valve opens the way that it's supposed to. Now, another thing that this schematic doesn't really have a good indication of is there's an airflow sensor in here. So there's an airflow sensor located like right here, right? And again, this is not to scale or anything. I'm just guessing where it would be in here, but it's got to be before the valve itself, because what happens is the valve opens, air gets pulled through, and then that airflow sensor is going to detect airflow coming through. And when it does that, that's when it knows that it's cooling at this point. All right, and that's where this is coming in over here. So no cooling. Okay, so we talked about the overheat light at the standby position gets inhibited for 5 minutes. The no cooling light, which is located over here, that's going to indicate or inhibit for 1 minute. That's all it inhibits, because that light tells me there is zero airflow going through the system. And that's telling me that I'm at the end. I've gone to standby, didn't work. Gone to override, didn't work. So that's it. You're not cooling the airplane, and you're not cooling the equipment anymore. So in that particular case, that's where I think most QRHs are probably going to say land at near a suitable airport. And again, you got about 90 minutes before you start losing essential equipment. What that essential equipment is, I couldn't really tell you. There's not a list given really for that. But just imagine that it's things you probably need to land and that you need to navigate and fly. So it would be in your best interest probably to find a place to land. So we go to the override position. This light gets inhibited. After 1 minute, if there is no cooling that is detected in that particular area, the no cooling light will illuminate, and that's going to be your problem. Then you're going to follow the QRH for its directions. More than likely, it's going to tell you got about 90 minutes before you start losing stuff, and that you got to land at the nearest suitable airport. Okay, but again, follow your QRH, follow your company procedures, right? Okay, third and final fault light, I guess. It's going to be a smoke light. So smoke light, that's pretty self-explanatory, right? Inside the system, there are detectors for smoke. And if like your exhaust fan or something like that gets smoke because it's burning up or because it's coming from the conditioned air or something like that, it's going to detect that smoke and it's going to give you this light. Now, as I've said before, follow the QRH, point the switch to the light like it's probably going to tell you to do. Boom, point the switch to the light. Smoke light will extinguish when the smoke is no longer there. The no cooling light will again be inhibited for a minute because we need to get that airflow, right? We need to sense that airflow coming across that sensor. After that minute, if for some reason it's just not, the valve didn't open or there's no airflow there, and no cooling light comes on, and now you got all kinds of issues that you still got to fix, because now you got a problem where you had smoke. You can't go back to the auto position. You can't cool the airplane or can't cool the equipment by going into the override position because the valve won't move. So again, you're stuck at 90 minutes losing things, landing at the nearest suitable. Now, what I would do, I'd be flipping that switch, just trying to get a signal. Maybe it's a signal issue. I'd flip it more than once, but that's just me. Again, that's going outside of any manual, any procedure. But the last thing I want is for that to be my issue. But who knows? Who knows? It could be a faulty switch. So, I mean, it may not be even switching. You just don't know. That's the thing. And that's why you got to follow the QRH, because it's going to direct you to the safest course of action. Like I said, when the smoke light extinguishes, the smoke's clear in the system, and then you can continue on. Now, notice again, this is showing a normal in a standby mode here, and I've got the switch and override. That's not the way it's going to be. It's going to be like this. And if this like that, there we go. If it's like this, where there's no smoke light, there's no cooling light, and we're in the override position, it's fine. You can continue that way because you're getting airflow through that system. That's the big thing, is getting airflow through that system. Now, that is it's 20 minutes, but it's still a quick overview of that equipment cooling system. Okay. In the aft part of the airplane, there is a aft equipment cooling center. There are zero controls, zero indications, zero anything for this. This is 100% automatic. Now, what it does is it has conditioned air that gets blown through that aft equipment center, and there are two fans. You got one, they're both exhaust fans, they're both back at the outflow valve, and this one is on and it's pulling through. If this one were to fail, this one is automatically supposed to turn on and pull that through. Again, you won't know it. The only way you'll know that system isn't working is if stuff starts to overheat and you lose it. So this is more of a informational slide than anything, because you don't have any way of controlling it, no indicators, no anything, right? So take with that what you will. Now, some airplanes, generally this is the ETOPS airplanes, but these what are they called? Electrical equipment cooling monitors. This is a maintenance only thing. This is maintenance doing a test on this to see where the failure in the cooling system is. So I'm trying to think of a good example of how to compare this to something. If you've ever watched, I don't know, the lottery, when they pull the ball out, right? It gets pulled up into that tube, and then they pull the ball out, and then, oh, here's your number. That's what these are. They're vacuum. They're hooked up to vacuum tubes. So this is the P61 panel, or the accessory panel, or the FE memorial panel, however you want to call it, in the 7.6. It's the one that's right behind the FO seat, directly behind them. And on the top part here, you'll see that it's got this cooling monitor. If you go over to it and you push that test and you go like that and you push it up, right? What you should see is you should see all these white balls come up into view, because you're kind of opening up that vacuum or closing off the vacuum, however you want to look at it, to where it creates a suction for those to come up into view. Whatever ball doesn't show up, that's where the leak is. And it could be a tube that's disconnected down there. It could be a hole. It could be whatever. But that's where your disconnect is going to be for your equipment cooling. So this is where I would probably say I would call my essential equipment. Because again, if it's ETOPS, usually these are ETOPS airplanes that have these installed. Not every airplane has them installed, but essential equipment for ETOPS is going to be basically what's on here. ADI on the left, HSI on the left, VOR, FMCDU on the left, and then you got IRU right, center, and left, and then whatever's located on E1, E2, and E5. I don't know what's located on there, but whatever's in those particular racks, I would probably say is what's your essential equipment. It's just a guess. But anyway, that is a quick rundown of the equipment cooling system on the 767. I know it's a painful system. People don't like it. They don't learn it, and that's fine, because it is all automatic. And you just flip a switch when the QRH tells you to, and it does stuff automatically. But for you nerds that are like me that want to learn more about the airplane, learn more about the systems themselves, this is a good introduction into what that system is. Okay. Now, as of the recording of this video, it's 8:45 p.m. on February 3rd. I have 99 subscribers, because we're on YouTube. At 100, I'm going to do something. I don't know what. I'm going to do something, because, I don't know, triple digits is a big deal. And then I'll do something again at 1,000, so on and so forth. So please like, share, subscribe to the channel. Pass this along to anybody that you think might gain knowledge from a 7.6 standpoint, or needs to gain knowledge from a 7.6 standpoint. Yeah, there's going to be other information in the description. You can reach out to me at training@gsiguybrandon.com. Brandon at gsiguybrandon.com, gsiguybrandon at gmail. I don't care. You can reach out to any of those, and I get back to you. You can leave a comment in the thing below here. It's all. I try and get into all of it. I try and follow all of it and whatever else. All that I ask is that you're respectful in what you say. That's all I ask. There's also going to be a Google Drive that's in the description as well. If you have any issues with it, please let me know. There are going to be some PowerPoint slides and stuff that are on there. I'll put this on there, even though there's no notes or anything along with it. It just gives kind of the breakdown of it. So, I'm trying to do as much as I can for you guys. I like doing this. I like teaching, and this is really what I want to keep doing. So, again, push it, share it, like it, subscribe. And I'll see you guys on the next one. See ya.